My name is Dr. Andrew Doan, and my talk today is on technology and the child's mind, what we know, what we don't know, and how we're destroying potential as parents. I have a doctoral degree in neuroscience, and my expertise is in learning and memory, as well as now addictions, as I tell my story in the book Hooked on Games. I do have financial disclosure. I am the author of Hooked on Games, which is available on Amazon in print and Kindle version, as well as Barnes& and Noble and other online retailers. I'd like to start off with discussing the concept of how we learn how to ride a bike as individuals. So there's a point when our brains get it. When we learn how to throw a baseball or hit a baseball or even catch a baseball, there's a point in our brains that get it, and we're able to learn new activities, behavior, and also new concepts. This is my daughter Emily, and 2 months ago we were camping and she wanted to learn how to ride her bike without training wheels. So we got to the point where we took off the training wheels and I was practicing with her, and this is the moment when she was able to coordinate her muscular movements, her pedaling of her bike, her balancing, and also to have confidence that she could ride the bike. And this is the moment when her brain got it and she was able to ride. So what's interesting is the answer to this is actually we really are able to learn new things as human beings, even from the time that we are a little baby to the time that we're older. Our brain is constantly reshaping itself, expressing what we call plasticity in order to learn new behaviors. So, how do we unlearn to ride a bike? The answer is we can't. We have to be very careful in how we expose new behaviors and new activities to our children, because once they learn an activity, there is no hope of really unlearning that activity. So even a 90-year-old person who is healthy, who has learned how to ride a bike when they were 6 years old, as long as they're physically able to ride that bike, they remember. They get on and they ride that bike. They can pedal, they can coordinate. So even after 80 years from the time that they first learned how to ride that bike, the brain keeps those memories. So how does the brain keep the memories? Well, within literally 15 to 30 minutes of exposing an individual to a new learning situation or a new environment, the brain expresses in the hippocampus, in the different areas of the brain, of the motor cortex and other areas that is associated with learning how to ride that bike or perform other activities. These areas are expressing what we call immediate early genes. These immediate early genes consist of a class of proteins consisting of like c-MYC, c-Jun, c-Phos. These are all zinc finger transcription factors that bind to DNA and initiate a cascade of expression of other proteins and other elements in the brain that allows the brain to be plastic, meaning that the brain is constantly changing itself in how it expresses these genes and how it expresses these proteins to make new connections, reinforce existing connections, and also to reinforce certain neurotransmitter receptor interactions in the brain, and hence leading to a learned behavior. So once that brain turns on enough of that pathway to learn how to particularly do a certain procedure or a behavior, it's almost impossible to unlearn that behavior. So in 1930, B.F. Skinner did a classic experiment where he taught rats how to push a lever for a food reward. Now, the lever pushing produced a food reward. That could also be a lever giving a reward of sugar water. What he theorized and concluded was that you can train a mammal to do any activity if given the right reward. So in these technologies that we're seeing today, we are seeing children who are being rewarded with a digital drug, something that makes them feel good, something that helps them to escape, something that helps them to receive gratification. And so, literally, the lever pushing that we do with our mouse buttons, our keyboards, these are leading to a behavioral tendency in our children at a young age. So if you expose a child too early to, let's say, a tablet computer, and they're learning how to surf on YouTube, finding the particular videos that they enjoy, there could be a problem. I talked to a good friend of mine the other day when he has a 3-year-old daughter who knows how to navigate the iPad, who knows how to get on YouTube and looks for the videos she likes to view. Now here's the problem. She has to do this before bedtime, otherwise she won't settle down to go to bed. She'll cry, raise a fit, she'll sleep with the iPad, and the other night she was up till 2 o'clock in the morning surfing YouTube videos, and every time the parent tried to take away the iPad, she was crying. So instead of being parents and doing the difficult thing of taking the iPad away, they actually fostered this addictive behavior in the 3-year-old, now who would throw temper tantrums, who would cry, who would actually exhibit anger and frustration when they remove that technology from her. So what do you think that's teaching this child at the age of 3? Because the brain now is learning that that's what it likes to do. That child, when she develops as a teenager or even later in adult life, may become dysfunctional because that's how they learn how to interact. That's how they learn to pacify their boredom, and that's how she has learned to basically calm her before she goes to bed. So, is video addiction or video game addiction or technology addiction a clinical diagnosis? The answer is no. The American Medical Association, the Psychiatric Association, has not added this problem into what they call the Diagnostic Statistical Manual for Psychological Diseases, the DSM. So that's not existing. But this is the analogy I use to argue that video game addiction and technology addiction should be a problem and should be a clinical diagnosis. So the ICD-9 321.31 is the diagnostic code for problem gambling, or also known as ludomania. In problem gambling, this is an impulse disorder where the individual is gambling for a rush of dopamine and adrenaline that prevents that individual from making logical choices. They will spend all their money for the next high. They spend all their money hoping to win back their losses, and hence can develop a behavioral addiction that can lead to their downfall emotionally, physically, as well as interpersonally with their relationships with others. So video game design is very similar to gambling. So this is the way I describe it. So let's take the classic games of the role-playing games where you're a warrior and you're traveling through the woods and you kill these creatures like bears and tigers and maybe sometimes demons and even the devil himself in some of these games. And upon the successful killing of these creatures, there's a random drop that occurs, so a treasure chest. At that point, it's kind of like pulling the lever on a slot machine. The individual then opens up that chest and see what kind of magical item is in there. Sometimes there's magical rings and magical swords, magical bows, and these items actually have cash value. Even if they don't have cash value, they have time value because it took a certain amount of time to gain that item. So therefore, if I'm a doctor and making $100 an hour and I play a game for 5 hours to get a magical item, that item to me is worth $500. But these items too on the internet are worth hundreds, if not thousands of dollars. And in the game World of Warcraft, every year there's $100 million of US dollars that are being exchanged with other individuals for virtual gold to buy these virtual items that have value in the game. So hence, if video games are similar to playing the slots, because people are repeatedly killing these creatures in these games to gain virtual items that have value in money that can be sold, and problem gambling or ludomania is a clinical diagnosis, then wouldn't it make sense that there are some individuals who would be prone to a video game addiction problem? And hence, video game addiction and technology addiction should have an ICD-9 code. And why is this important? Until it becomes an official clinical diagnosis, no one's going to take this problem seriously. No one's going to take this problem seriously, and therefore insurance companies will not pay for the treatment of this problem. But Douglas Gentile, a doctoral researcher at Iowa State University, performed a classic study showing that about 1 in 10 kids are addicted to video games, similar to problem gambling. So why do people develop these problematic behaviors such as addictive gambling, eating disorders, and then also possible video game and technology addictions? Well, it happens to deal with the stimulation of dopamine. There are classic studies that show that video games stimulate dopamine in the brain. That's not a surprise. Anything we do that's pleasurable has that benefit of stimulating dopamine. So this is the neurotransmitter and the chemical structure for dopamine. Well, dopamine is made at the presynaptic terminal, and then it's released, and then it binds at the postsynaptic terminal. Now, the amazing thing is that dopamine falls in the class of neurotransmitters called the tricyclics. And the tricyclics consists of dopamine, serotonin, and norepinephrine. And what's interesting is that the classic antidepressants increase the dopamine, serotonin, and norepinephrine at the synaptic cleft, meaning that by taking a pill, psychologists and psychiatrists can raise the level of these catecholamines in the brain to make people feel better. So if you have enough of these catecholamines, you feel pretty good. If you don't have enough, you get depressed. So what's interesting is that a behavior that stimulates dopamine can act as an antidepressant. So if these video games are literally digital antidepressants, by playing these games, by surfing the internet, by doing things that are fun in a rapid fire fashion, it can actually raise the level of dopamine in the brain, making the individual feel good. However, the brain is very smart. It knows that if there's too much dopamine, it has to back off its response to dopamine. And therefore, it produces an effect called tolerance. So in tolerance, an individual has to do that behavior more in order to get the same effect. So this is why sometimes when people get addicted to gaming or the internet, what was 2 hours now becomes 4, becomes 8, becomes all night, because they need more and more time in that activity to feel good. But the problem with the video game that's never ending, there is no refractory period. These individuals can sit there all day long for 24 hours, 40 hours at a time, just basically clicking the mouse and feeling good. And hence, this is why there's been reports of deaths. There has been a report of a death of a 20-year-old man who played Xbox for excessive amounts of time, and he developed a deep vein thrombosis that traveled to his lungs, and he died from a pulmonary embolism. There is another case of a person who played games for 40 hours straight, forget to eat and drink, and died from a cardiac arrhythmias. So people are actually dying because they artificially raise their levels of dopamine in the brain, and so they lose their sense of hunger. They lose their sense of pain that they're going through. And this brings up an interesting topic. So video games are sometimes used in the clinic setting to distract the child so that people can do painful procedures, such as taking blood samples or giving a needle stick to the child. So in essence, these video games can act as a digital drug that is powerful enough to distract an individual so that painful procedures can be done on them. So what do we know about video games in the brain? Well, here's a study performed in Comprehensive Psychiatry in 2011 titled Brain Activity and Desire for Internet Video Game Play. What this study found was in a functional MRI scan, the dopamine pathways in the prefrontal cortex that is responsive to pleasurable activities light up in the brain when people play video games. What's also interesting is that if you compare some of these brains with people who are addicted to alcohol or drugs, their brain scans can look very similar. So this is amazing evidence now that video games can stimulate the brain in a way that simulates a digital drug that becomes pleasurable. So why do people dive into addictive behaviors? Well, typically people are running away from emotional baggage, emotional hurts, emotional habits that allows them to feel horrible. So they're using addictive behaviors to basically escape. So when a person is drunk, they feel a little smarter. They also feel more attractive. Inhibitions are released or reduced, so therefore they feel more capable of doing things. So similar to an alcoholic, a person who is addicted to video games could be seeking purpose and challenge in their life. This is a game, Warcraft 3, where the individual controls troops and they fight real time against other human beings and allows them to conquer, destroy, and um, and really get that sense of purpose and challenge. In real life, for example, if someone goes to the military, it may take more than 30 years to achieve the ranking of admiral or general, but not everyone's going to get there. But in these games, everybody is a general, everyone's an admiral, everyone's a commander and a leader. And so, really, in real life, being hard, that requires hard work, sweat, and dedication, these games dupe the mind into thinking that we're accomplishing things and giving us a sense of purpose and challenge in life. Another element that the reason why kids and also adults are running to video games is they give us a sense of ego and leadership and pride. This is a screenshot from the World of Warcraft where every single avatar or character here is controlled by another human being. So in essence, these digital images and digital characters give the individual a greater sense of ego and even possibly leadership, because the gentleman in the front is leading a group of people to war and battle, and also gives us a sense of pride because now they're working as a team and able to conquer and attain loot and also work together so that they are winners. In real life, their real life could be falling apart, but in these digital worlds, they are somebody, they are something. What's interesting here is that people can also have the sense of love and acceptance. Nick Yee out of Stanford did a research study on gamers, and he polled thousands of gamers and asked them, how do you value your online relationships with other gamers? And approximately half of men and over half of women valued their online relationships as being more valuable or just as valuable as their real life relationships. And this is incredible. So as the graphics are getting more complex, getting more realistic, there are going to be more people who are unhappy with their physical selves, who are unhappy with the blemishes on their face and unhappy with the way they look, will run to these digital worlds, create their perfect self, and have these relationships online. So how do I know so much about this whole technology and video game addiction? Well, I'm a video game addict. Uh, I really was in these games as a young kid because my parents felt like they were good for me. So they introduced me to computers way too early. I learned that I should stay away from traditional addictions like drugs and alcohol and gambling. But video games, it's safe, right? So I could play as many hours as I wanted. But when I hit medical school and I was kind of bored with medical school, and really I was a broken individual. I grew up and I was very I was constantly picked on because I was Asian. I had troubles. I had basically lack of esteem. And so I would chase the ego and leadership, acceptance and love in these games because I was able to feel stronger and more powerful, and I felt like I was somebody. And it led to literally an addiction where I was playing 50 to sometimes 100 hours a week for over a decade. It got to the point where I became verbally and physically abusive to my wife. My wife moved out. She slapped a restraining order on me. She took the kids away, and really, literally, I almost lost my life because at that point in time when she did that, I had only 2 years left to go in medical school, and I was going to commit suicide. I was going to kill myself. And eventually, the gaming addiction got so bad where I developed carpal tunnel from my right index finger all the way up to my forearm. And I was also 30 pounds overweight, so I had problems with my weight and hygiene, and I developed an armpit hair infection that streaked down my arm in my right. So it got to the point where I couldn't even do intraocular surgery as well. I had to take maximum ibuprofen and Tylenol just to write in the medical charts and to function as an intraocular surgeon. I literally was killing myself, killing my life, killing my marriage, and destroying my chance as being a doctor. So finally, I went cold turkey. I was agitated and all these other problems, and finally I was able to turn my life around and focus and stay away from these addictions. So I really learned that by having a strong mind, strong body, and strong spirit, we are able to resist addictions. And when your mind is strong, you're sharp, you're intelligent. When your body is strong, you're healthy and you can avoid diseases. And when you have a strong spirit, you have integrity and you do what's right. These three components are like a three-legged stool. Without one, the other two will fall. So everyone has to have this mind, body, spirit as being central. For me, it was my faith in God. And without his intervention, I would not be here today to share my story. But you remember the concept of how do we unlearn how to ride a bike? We can't. I even tried moderating games. I tried to moderate the World of Warcraft, and my colleague dropped down a CD of that game, and I relapsed 1 year where I lost literally 2 months of my life. I put in 1,400 hours, which is 59 and a half days of gaming straight over the period of 1 year. And literally, my life was falling apart again. So once I've learned how to do an addictive behavior, I can't unlearn that. I can't not, I cannot jump in there and not be obsessive about it. So what we don't know can kill us. So way back when cigarette companies were giving out free cigarettes to people, they also had cute cartoon characters marketing to kids, and they were now obviously having added nicotine in there and titrate the cigarettes so that they become addictive. Well, we didn't know back then that being addicted to cigarettes are or actually could lead to lung cancer and other health problems. Well, same with alcohol. For the longest time, it took 30 years for the medical community to accept alcoholism as a true clinical diagnosis and problem. But for the longest time, people thought it was funny. People thought it was funny that people got in their car, crashed into trees. You saw it in movies all the time. And it was funny to see people in a drunken state and how stupid they look. But now we know that having alcoholism could act poorly on the liver and our organs, causing end-stage liver disease, can kill us, and can be a serious problem. Well, we really don't know the outcome of technology and video games in the long run, but we do have enough data to show that there are people who are emotionally and physically being permanently damaged from these things. And we also have now incidences of people dying from playing video games too much. And so what's interesting is that what we don't know can really kill us and kill our kids' potential. Brain plasticity refers to how the brain restructures and reorganizes after it learns how to learn. And what's interesting is this is a peer-reviewed publication in NeuroReport in 1998 showing that there was reorganization of the brain areas that were responsible for the sensory of the index finger. And there was reorganization after amputation of that index finger. What the findings in this research paper showed that the neural networks within the area of the amputated finger, within the brain areas that what we call the somatosensory cortex, that were responsible for receiving sensory inputs, were actually being taken over by neighboring neurons that were serving the thumb and middle finger of the right hand. So this is crazy. So this is a showing that basically even after a brain has formed and other structures have innervated the areas of the brain that controls the function of the index finger and also the sensory of the index finger. Here is an amputation that causes restructuring of the brain. That means the brain is plastic and constantly changing. So imagine if we only teach our kids how to text with their thumbs. What sensory deprivation are we introducing here versus a child that's learning how to write cursive with all their digits and trying to do other motor functions that are involved with classic educational language development? So my theory, and this is unproven, that I believe that we could be causing sensory deprivation that can lead to less effective communication skills. What's my basis for this? Well, there's something in my field in eye surgery called amblyopia, which is lazy eye. So as a child, if there's one eye that does not work as well as the other eye, the good eye takes such a prominence in the occipital cortex, the area of the brain that controls vision, that now the bad eye has no chance. And if we don't do anything about it, what happens is the child will grow up to be an adult where the bad eye becomes almost useless. So the vision is poor in the bad eye. So in order to fix this in a child, we actually patch the good eye. We patch the good eye, forcing the child to use the bad eye. And over time, the bad eye becomes as good as the good eye. And so this is why there's a picture here with the child being patched. So there is evidence that if we don't use an organ, in the case of this scenario of a bad eye, if we don't use that bad eye, then there is sensory deprivation and restructuring the brain to the point where the brain ignores the bad eye as an adult. So therefore, if we are introducing technology too early to our children, what sensory, what behavior, what cognitive, what language development are we causing them to be deprived of, and therefore having their brains hardwired in a way where they are not able to communicate and function properly as an adult? So are we killing potential in our children by introducing technology too early? I would argue yes. So what's interesting is that there was recently published in the news that executives from technology company are sending their children to schools that don't have technology. They would graduate from high school without technology, and they don't even use technology at home to write papers and do projects. So what's interesting is that I grew up with very little technology in my schools, and I turned out okay. I'm an MD, PhD who graduated from Johns Hopkins. And so the argument that parents want their best for their children, so therefore they're introducing technology at an early stage, like even at 2 years old, are we killing potential in our children because now we are depriving them of other activities, coloring, artwork, writing cursive, because now our children are being deprived of other sensory inputs from the environment because they're spending too much time on technology. Some kids spend 8 hours a day on the iPad or playing Xbox all day long. So that's their amount and extent of sensory input from their environment. So thank you very much for joining me today. My book called Hooked on Games, The Lure and Cost of Video Game and Internet Addiction by myself, and also written with Brooke Strickland, who's a good friend of mine and a professional writer. And the book is available on Amazon.com in print and on Kindle version, and also on BarnesandNoble.com. Thank you very much for your time and attention, and please join me on my podcast for additional lectures and additional discussions on video game and technology addictions. My website is andrew-doan.com, or also hookedongames.com. Thank you very much.